Hi, I'm Tony Stutterheim. In this tape we're going to take a look at the basics of LightWave Modeler. Now there's a lot of stuff in Modeler. It's a very powerful package and we can't cover everything in depth in this one tape. So what I'm going to try to do is get you oriented in Modeler, get you familiar with the modeling process, and also some of the tools that you're going to be using on a regular basis. So let's get started. Okay, so we're looking at the Modeler interface right now, and you can see I've already got an object loaded into the Modeler here. And let's just take a look at what the viewports are that we're looking at here. I should say before we get too far into this that I'm using the default menu settings, and you can make sure that you're using the default menu settings too if you're following along with me by going into Interface, Edit Menu Layout, and go over here under the Load and Save and click Default. Okay, that way we know that we're both running under the same interface and your buttons are where my buttons are. Okay, if you take a look at the interface here, we're running an orthogonal view. And basically what that means is we have a way of projecting or displaying a three-dimensional object on a two-dimensional flat screen. And the way we do that is basically by unwrapping a cube, if you will. And the top view would be the top of our cube. The back view would be sort of the face of the cube that's facing us, and the right view would be the right side of the cube. The perspective view up here lets us see what our model looks like in sort of a camera sort of view, or we can look at it from all angles. And I'm going to just rotate it around here by clicking the little rotate widget up here with my left mouse button and just moving my mouse around. And you can see as we do that we can see all angles of our model. Looking down at the y-axis, the z-axis is facing forward, and the x-axis is at the side. So that's the orientation of our model in the interface. Let's talk a little bit more about this x, y, and z business. Now x, y, and z axes are our way of determining where a point lies in three-dimensional space. So x and y are basically left and right and up and down, with y being up and down and x being left and right. And that gives us sort of a two-dimensional plane to have our point in space in. Now when we add the z-axis, that gives us depth. So it's either in or out, depending on how you want to look at it. So using x, y, and z, we're able to determine the position of a point anywhere in space. Okay. I should also mention just a couple other quick things that we can use on these menu bars here. We can go in and we can pan our object around within the viewport by selecting the little pan icon up here, the little four-arrowed thing. Hold down the left mouse button and you see I can move that around within the viewport there. Now I'm not actually moving the object in space, I'm just kind of moving where my virtual camera is when I look at it. I can also go in and zoom in and out of my object by hitting the little magnifying glass up here, click on it with my left mouse button. If I move it left, I zoom out. If I move it right, I can zoom in and move it back out just a little bit. One other thing you'll notice here in the viewports, you can see there's a little plus X or plus Z up here, a plus X over here. Down here we have a plus Y and a minus Y. This is basically the coordinates of our world. And you'll see these dark lines in the middle here. This dark line running this way, this dark line running this way. And where they meet up is the 0, 0, 0 coordinate. Basically the center of our universe, the center of the world. Now when I'm moving things around, you can tell that the entire object is moving and the grid, this grid of coordinates is moving right along with the object. And so that's one way to know that your object isn't moving, just your viewport is moving. Now if our object was moving, the grid would stay stationary, and the object, the points and the polygons that make up the object would start moving around, and we'll get into points and polygons here in just a little bit. So that's pretty much the basics of the modeler interface, and like I said before, it is customizable. We're not going to get into that too much right now. There's a couple other things we can do very quickly. We can switch these views really fast if we want to. Right now I have this set to the top view, which is the default in this setting. But I can also just switch it to the bottom view if I want to, or the right view, whatever you want to. I can have two perspective views here if I want to. You see I have a perspective view now. You can adjust the shadings of these views. Like over here we have a solid shaded perspective view, and this perspective view is just a wireframe view. So it's all dependent upon how you like to set up your interface and how you like to customize it. So I'm going to go ahead and set this back up to our top view right now. Another thing as far as getting around the interface, getting things into the place where you want to see them, is the Fit tool. And I'm going to use a keyboard equivalent to do a couple of things here. And the first thing I'm going to do is use a keyboard equivalent to zoom out. So I'm going to use the comma key. I always think of it as the left arrow key, or the left, or the minus than sign, but it's actually the comma key. And so if I hit that, you'll see I zoom out. If I hit the period key, or the greater than sign, it zooms in. So I'm going to move it out. And then I'm going to pan my interface around a little bit. So if we get disoriented and we can't find our object and we want to get it back into our viewport here, or we just want to center it up in our viewport, we can hit the A key. So if I hit A, boom, it pops it back into the center of all of my viewports here. And there's another thing that we can do. I'm going to zoom out just a little bit. I can do a Control A, and that will fit it completely into whichever viewport I happen to have my cursor in, and it will sort of disregard all of the other viewports, and it will just fit it into the one I'm in. So this will become a little more obvious when I move my viewports around and resize them a bit. And the way that we can do that is by simply clicking with the left mouse button right in the center of all 4 windows right here. And so I'm going to click and hold down, and you see that the lines there sort of change color and they brighten up. And as I'm holding down, I can move the mouse around, and you'll see that my viewports resize depending on how I move the mouse around. So now if I go in and let's say make all of the viewports kind of small except the top viewport, and then I do the Control A to fit it just in this window. So Control A, boom, you'll see that my object gets fit into the window that just the one window that I wanted it in, and it disregards the other 3 windows and just puts them however it has to make it fit into this window. And so you'll see the difference if I just go ahead and do the A key. Okay, so now it fits it into all 4 windows. All right, I'm going to move my window back into the center here so that all the windows are even up. So that's pretty much how you get around your viewport. We've covered zooming in and out of your object, panning the viewports around, and being able to fit your object into any window that you want to. Let's take a look at how to create just a flat polygon out of 3 points or 4 points, and we'll talk about the differences between the two and the problems that you can run into, and a few other things about polygons in general. Okay, so if I go into the Create tab here and select Points, I can basically create a point in space. And if I click the left mouse button, I have a point that's been defined in space. Now I really haven't created anything yet, and I can drag that point around to wherever I want to. Now you'll see that the point is moving in the top view, and it's moving around in that dimension. Actually moving it around in the Z dimension and the X dimension because I'm in the top view. Now if I want to go ahead and create that point, I can either hit the space bar, like so, and you'll see I've got a little tiny point created right here. Now I can create points another way. I'm going to go down and select the Points tool again because it got dropped when I created the point. And now I'm going to use my right mouse button. If I click the right mouse button once, and then I click it again, you'll see that the point where I was before gets created. And so this is sort of a quick way to go in and create points. So now I've got 4 points created, and I'm going to hit the space bar to drop the tool and create this last point. Okay, so now I've got 4 points in space. Now you can see I can't see anything over in the perspective view because the points are basically just reference points for where the geometry gets stitched together, and so they're not rendered if they're just points. Now I can turn points into polygons and make a 1-point polygon if I want to, but LightWave allows that, and we'll cover that a little bit later. But for right now, I'm going to go over to my top view, and I'm going to select 3 of these points first of all and create a triangle polygon. So to select the points, I'm going to go down to these selection tools down here. We have points, polygons, and volume. And for right now, I'm just going to use points. So if I select points, you can see that they all become highlighted. And the reason for that is those are the last things that I created. And so they're already highlighted for me in the order that I created them. Now it's very important when you're creating a polygon by hand that you select the points to create the polygon in the correct order. When you're doing it with a triangle, it really doesn't matter so much because you've only got 3 points, and LightWave will know how you want the triangle to be created. But if you're doing more than 3 points, the order of the points the order that you select the points is actually very important. And let's take a look at why that is. Okay, so I've got these 4 points selected now. Let's just go ahead and create a triangle out of 3 of the points. And so I don't want all 4 selected, so I'm going to drop them by clicking in this blank area over here on the interface. So I've dropped the selection of the points. Now I want to go in and individually select these points. So the point selection tool selected. I'm going to move my cursor over one of the points and click on the left mouse button, and that point becomes selected. I'm going to do the same thing for this guy over here, but now you'll see if I try to click on it, it doesn't select. And the reason for that is I let go of my left mouse button after I had this guy selected. Now, to continue selecting these points, what I have to do is hold down the Shift key, and now you'll see if I click on it, I can get it selected. Continue to hold down the Shift key, click on the next guy, that gets selected. Okay, now I've got 3 points selected here. I can create a polygon now, and to do that I'm going to use the shortcut for Make Poly, which is just the P key. So P, boom, we've got a polygon. Okay, so now you'll see we have lines that connect the 3 points, and that defines our polygon, and that polygon is now a renderable polygon. You can actually see it over here in the perspective view, this little triangle. If I rotate it around, there's a polygon. Now if I go in and select the polygon selection tool next to the points selection tool down here, you'll see that the polygon lights up that I just created. But you'll also see that there's an extra line flying off of this polygon. This line right here in the back polygon. This is called a surface normal. And what the surface normal does is it lets you know what face of the polygon is the visible face of the polygon. Now, right now the polygon that we've created appears to render just fine. But if we rotate it further in the perspective view, take a look. As I rotate around here to the back side of the polygon, you'll see that the shading goes away. The outline is still there. And let me just drop the selection of this polygon for a second. Okay, boom, what happened to our polygon? Well, it's still there, but it's not visible from this side. So if I rotate back, oh, there it is. Now, what clues us into what side is visible and what isn't is the surface normal. So if I select the polygon again, polygon selection tool is selected, and if I just left click on an edge of this polygon, there we go, it highlights, and we can see the surface normal go flying off sort of perpendicular to this this triangle, to our polygon right here. And so that tips us off to which way it's facing. Now I can flip this normal and make the polygon face a different way if I want to. And there's probably going to be a lot of instances where you're going to want to do something like that. And so the easy way to do that is just with the keyboard equivalent, which is F for flip. And keep your eye on the perspective up here when I hit F. Boom. Okay, did our polygon disappear? No. It's just facing the other way now. And you'll see that the surface normal is now pointing exactly the opposite direction as it was before. Okay, so what if we want a polygon that is visible from both sides? Well, that's a very easy thing to do as well. And let's check that out. Okay, so we've got our polygon that's visible only on one side right here. How do we make it so that it's visible on both sides? That's very simple to do. We go in and we copy this original polygon. So I'm going to go down here to the cut, copy, and paste bar, and say copy. And then I'm going to flip this normal again. So F for flip. And now I'm going to paste my original copy that I did. And remember, the original copy had the normal facing the other way. So if I say paste, it pastes a polygon right on top of the one that I had here before, except that now you'll see when I rotate, oh, okay, now we can see the polygon from both sides. Now we basically got two polygons sharing the same points right there. Sometimes you want that and sometimes you don't. In an instant like this where we just want a double-sided polygon, we want to do something called merging points. And what that's going to do is say that, okay, it's going to tell Modeler, okay, you've got a polygon here that has two sets of points for each vertex that it has in the polygon here. And so we want to go ahead and merge those points into one point. I'm going to drop this selection because I only have one of the polygons selected right now. So I'm going to drop it. Now I'm going to select both polygons again. Alright, so selecting them both in the back view here, you can see both normals flying off there now. And actually, if you look down here right above the points, it says selected, or SEL for selected, 2. And that way I know I've got two polygons selected here. Another thing, if I go in and I can tell if these points are merged or not by deselecting this, selecting one of the points with the point selection tool. So if I go in and select this point, and it looks like there's only one point there, but if I go down and look here under the selection, there's a 2, which means that there are 2 points there now. So I'm just going to drop this one point right here and show you another way that you can select multiple points at the same time without having to go in and individually select them. I'm going to hold down my right mouse button and start dragging around the polygon. And then I'm just going to let up. And whatever was in that volume or that lasso that I drug around in this view is going to be selected. And so you see all 3 points are selected. Now, again, it looks like I have 3 points selected, but this selection down here at the bottom above points shows I have actually 6 selected. Alright, so let's merge these things. And I can merge them just by hitting the shortcut, the keyboard shortcut of M. And it gives me different types of merge. Automatic, it just says, Modeler just goes, okay, I know that I have points in this object that are exactly the same coordinates. I'm going to make them 1 point instead of multiple points. Fixed, I can go in and give it an absolute distance between points. And what that means is that if 2 points are within this distance from each other, that they're going to be merged and merged into 1 point. And it's whichever the last point that you selected is the point that they're going to get merged into. Alright, so let's go back up to automatic. For most things, automatic will get you by. So I'm going to say OK. 3 points eliminated. Alright. Great. Okay, so now if we look down at our selection set, it says we have 3 points selected. And if we rotate our perspective here, you'll see we still have our nice double-sided polygon. Alright, so for most objects, a one-sided polygon is fine. Like a ball, you don't need to worry about going in and copying the ball, flipping the normals, and pasting it and merging it back together for most applications, like for a planet or what have you. Now, there are instances where that is important, which we'll talk about a little bit later. But let's get back to why point selection is important when creating polygons. Okay, so I'm going to drop these points that I have selected right now. And I'm also going to kill this polygon. There's a shortcut for that, and that is just the K on the keyboard. So K for kill, boom, that polygon is gone, and you'll notice that our points are left behind. Okay, so now I want to make a quad polygon, and so I'm going to go in and I'm going to select my points in order. So left mouse button, hold it down, and just drag them in a clockwise fashion and select them in a clockwise fashion. Okay, so 4 points selected, P on the keyboard to create the polygon. Okay, So that would be a quadrilateral polygon. And if I look in the perspective view, as you might expect, it's only one-sided, and that's just fine. Now, that's what it should look like. Now, what happens if we select these points out of order? What problems are we going to run into? Okay, well, let's find out. Let's hit the K to kill that polygon. And now I'm going to select them out of order. So select that guy, then this guy, and then down here to this guy, and then back over to here. And now let's hit the polygon. Oh, that's not good. Okay, modeler's confused now. He doesn't really know how you want him to make this polygon. And you'll look over here in the perspective view. If I rotate it, I'm seeing different sides of different polygons, and it's messed up. It's basically just messed up. And if you have polygons like this in your object, you're probably going to get all kinds of rendering errors in LightWave. You're probably going to get flickering polygons or just black holes in your polygons. So this kind of demonstrates why it's important to select those polygons, or to select those points in order. By selecting them in a clockwise or even a counterclockwise order, LightWave or Modeler will know, okay, how the surface normal should face and how to create these polygons. So I'm going to kill this again, and then I'm just going to go in and add a few more points here. So right-clicking around these points. And so you'll see I can have, and now I'm going to deselect them. So now you'll see I can actually have more than 3 or 4 points to create a polygon. So I'm just holding down the left mouse button and going around in a clockwise order here. If I hit P for polygon, there we go. Now, one thing to note is that all of these points lie in the same plane. Down here on the back and in the right, you can see that all of the points are in exactly the same place on the y-axis, and that's very important. If we take one of these points, and I'm just going to select one of them, and do a move on it, and a move is a new thing that we haven't covered quite yet, and this is actually moving geometry around. I'm going to hit the T key to activate the move tool, and you'll see my cursor changes. We can also find the move tool over in Modify. If we click on the Modify tab, you'll see the move tool is already selected. Okay, so let's move this point. So I'm just going to hold down the left mouse button over here in the right hand view, or in the right view, and move my mouse up. Now let's take a look at the perspective view. Okay, we've got some problems with our polygon here. And you can see that it's shading it kind of funkily right now. And that's because we have what's called a non-planar polygon. And that means that all of the points that make up the polygon do not lie in the same plane. Now, you can get non-planars on anything with more than 3 points. Obviously, if you have 3 points of a triangle, those points are always going to lie in the same plane. You can't get them out of the same plane. But if you have 4 points, one of those points or one or more of those points could be out of the plane of the other points, and you're going to get these problems. So if you see strange rendering errors in your object, you might want to check for non-planars, and there's a way that we can do that. Let's take a look. All right, so the way that we can check for non-planars in our object and correct them is by bringing up the statistics menu. Now I can do that with hitting the W key, and that brings up point statistics if I have points selected, in which I do have points selected down here. And so I'm going to get rid of that because I actually want polygon statistics. So I'm going to go down and I'm going to select polygons instead of points, and you can see that the last polygon I created becomes selected, and that's fine. Actually, I'm going to drop that polygon right now, so click in the blank area. Okay, so now you see we have polygon statistics, and it tells me how many total polygons I have. Right now it's set to 1. How many faces I have. That's set to 1. How many polygons that have 1 vertex, 2 vertices, 3 vertices, 4 vertices, greater than 4 vertices, and how many are non-planar. Now, if I go in and select the little plus widget here, it's going to select in the interface whichever non-planar polygons I have. And you can see right now it's already telling me I have one non-planar polygon in here, and it's the only polygon I have. So if I hit the plus key, okay, now I have this polygon selected. So an easy way to go into your object, if your object has lots of polygons, and find out which ones are causing problems because they're non-planar, is just to go in the statistics menu and look at the non-planar and select them with the plus key. And I can also deselect them hitting the minus widget, but I'm going to go ahead and leave this guy selected. Okay, so let's go ahead and get rid of the polygon statistics here. Alright, so now how would I fix something as heinous as this right now? Well, I could go in and try to manually sort of fix this point by putting it back into the plane where I want it, but maybe I actually want this point up here for some strange reason. Well, the way I can fix the non-planar issue is by tripling this polygon. And basically what that will do is turn this polygon into all triangles. So let's just go into the keyboard equivalent for triple, which is Shift-T. And boom, you'll see all kinds of triangles have to be created to make the kind of polygon that we want. But now if we rotate our object around, you'll see that it begins to shade in the way that we think we might want it here. Alright, so now if we go back to hitting W and checking out the polygon statistics, go down to non-planars, we have 0 non-planar polygons right now, which is a good thing. You want to stay away from non-planars because usually they'll appear as holes or flickering polygons in your rendered scene. Okay, so I'm going to just delete this guy right here. Alright, so let's say we want to make a one-point polygon. All we have to do is select points and go out here and we'll make a point anywhere we want it. And I'm just going to hit the space bar to drop the tool and create that point. Alright, so right now you'll see that if I select point selected, it already has selected the last point that I created. Now if I want to make that a polygon, I do it the same way that I did with all the other polygons, and that's just by hitting the P key. Okay, now it's kind of hard to see, but over here in the perspective view I can actually see a little tiny point right here. Now the problem is just because it's a point, a one-point polygon, it doesn't get any bigger. So if I try to zoom in on it, it's just going to stay the same size, but it will move around a bit. So I can't make that point any bigger because it just defines a point in space where a single point polygon is. Now, one way that you're going to use this is for star fields or for particles, and the only way to adjust the size of that one-point polygon is in LightWave itself. And there are options in LightWave that let you change the thickness or the size of single-point polygons or two-point polygons. And we're not going to get into that right now, but I will show you what a two-point polygon looks like. Alright, so I'm going to go ahead and delete my one-point polygon here. And now I'll just create 2 points using the right mouse button to click and automatically create them. Now that they're already created and they're already selected, I can just hit P to create a 2-point polygon. Now this guy has sort of the same problem that the 1-point polygon does. If I try to zoom in on him, you'll notice that the line itself doesn't grow any thicker or any bigger. The points that make it up just get further and further apart. And again, the thickness of this line when it's rendered is adjusted in LightWave. And LightWave has options for adjusting that. So let's get into making some actual objects here. And the first object we're going to make is a box. And under the Create tab, you'll see the Primitives menu. And under Primitives we have box, ball, disk, cone, sketch, text, and pen. So let's go ahead and select the box button. And now I'm just going to go out to my interface and I'm going to just drag out a box. And the way you do that is by holding down the left mouse button where you want the box to start. And now I'm holding it down and I'm just going to start dragging it sort of down and to the right. Okay? Now we haven't created a box yet. We're just beginning to draw out the dimensions. And you can see right now I've basically got a flat plane over here. And if I just rotate this perspective around, you'll see that this box, it really isn't a box yet, it's just a plane, it's just flat. So there's really no depth to it yet. So the way we fix that is just by going to a corner in one of the other views where we can drag out some depth into the box. So I'm going to go ahead and click the left mouse button again on that corner, and now I'm going to drag it up. You'll see I'm starting to get some depth over in the perspective view here. And so now we actually have a box starting to form. And in the perspective view I can go in and grab as well, right in the middle of this part of the box, this side of the box, hold down the left mouse button, drag to the right, and I can stretch that box out however I want to. And I'm going to go back down here to the back and drag down the box a little further. Pick up the top so I have a nice symmetrical box object. Okay. And now to create that box, I can either go in and drop the tool by selecting another tool, or I can hit the space bar to create it. So I'm going to go ahead and use the space bar to drop my tool and at the same time create the geometry. So space bar, boom, this box is made. Alright. So now you can see we have a complete three-dimensional box in our perspective view, and in our other views we have the flat representation of it. Okay, now there's another way that we could have created that. I'm going to delete this box right now and show you the numeric requester. So I'm going to go ahead and hit X, and now I'm going to select the box tool again, and now I'm just going to hit N on the keyboard for the numeric requester. So N pops up the box tool, the numeric requester for the box tool. Pretty much every tool has a numeric requester for it in Modeler. And numeric requester is great if you want to be very, very precise and type in the coordinates of your object instead of dragging them out. You may have very precise coordinates that you know that your object needs to be, and it's great to be able to go into numeric and just type those in rather than trying to drag it out and get it exactly right. So let's take a look at how we do that. So right now if I want to go in and start creating a box, it remembers the last thing that I drug out by hand and puts that into the numeric panel here. So if I just go into these little spinners over here on the right hand side and start adjusting them, you'll see, I'm going to resize this panel just a little bit, you'll see that the box starts to change its shape depending on how I drag, which slider I drag in the numeric requester. Now you'll also see down here in the numeric requester these segments fields that you can enter numbers into. And basically what that means is how many segments the box will have on a per side and per dimension basis, or per axis basis. And the easiest way for you to figure out what that means is for me to just show you what more than one segment looks like. So take a look when I move the X segments to more than one. Boom, you'll start to see along the X-axis down here, the views that show you an X-axis, the top and the back, that I'm starting to get more and more segments within my box. And that basically means that my box is going to have more faces or more polygons in those dimensions. And I can just keep doing that in all of the dimensions if I want to. If I go to the Y, drag out some more segments, you can see down here where we can see the Y that now we have sort of this grid going on down here. And then if we want to do the same thing in the Z, all I have to do is drag out some more segments, and now we have kind of a Rubik's Cube looking thing. And so those are some of the things that you can do in the numeric requester with the box tool. Okay, so you may be wondering, well, why would I need more than 6 sides in my object? Why do I need all of that geometry in a simple box object? Well, if you're just creating a simple box, you wouldn't. But there may come a time when you get more advanced in Modeler that you're going to need to be able to add geometry to simple objects to turn that object into other objects. Okay, I'm going to show you one other thing that you can do before we get rid of our box here. I'm going to zoom out just a little bit for this, so comma key. Now before I create this box, I can easily go in and create multiple copies of it. So I'm just going to size out this top window a little bigger. And then I'm going to, with the right mouse button, I'm going to click on the center of my object here and hold down. So holding down the right mouse button, click, and you can see as I start to drag, I'm starting to drag multiple copies. I let up, click and hold down again in the center, and I can just quickly keep doing that, hold down the right mouse button, and keep dragging out as many copies of this object as I want. Now I don't just have to do it in this view. I can go down to one of the other views, say the right view, find my cursor, my center point of the box object, right click on that, and you see I can grab it and move it around, creating more and more copies wherever I want to put those. So that could be useful if you're like making a city and you want to make all kinds of different sizes of buildings. And you could very quickly go in and resize a few of those buildings. Hold down the left mouse button on the center cursor and I can move those boxes around. And if I do it on the right mouse button, it creates the copy and I can drag that out as a new copy. So it's very cool. I can create these multiple copies and I can go in using the left mouse button to adjust them, and once I have them adjusted like I want them, I can go in with the right mouse button, hold it down, grab that, bring it out, and then left mouse button, adjust it some more. And you'll see I'm getting quite a collection of boxes here in my perspective view. And remember though that this last box here that I drug out, the one that still has sort of the highlights around it, that basically means that box hasn't really been created yet. And if I don't drop the tool, that box will just go away if I start doing something else. So I want to go ahead and create that box. I'm going to hit the space bar, and there that box will stay there. Okay? Alright, so our interface is quite messy here, so I'm going to get rid of that. Now let's take a look at the ball primitive. All I have to do to create a ball is go over and select ball, and it's exactly the same as dragging out a box, except you'll see that when I start to hold down the left mouse button and drag it out, I'm actually dragging from the center of where my ball is going to be. And so if I keep dragging this in and out, I can get it to a point where, okay, that's about the size I want the ball to be. Oh, maybe that's not right, but I can't quite see how big this ball is getting, so I want to grab the center of it. So just like the box, I can hold down the left mouse button in the center, move it to the center of the viewport. And you'll notice over in the perspective right now that I just have a flat disk. And that's a real easy way to create a flat disk if you want to. There's also a disk tool, but if you just create this now, you'll have a disk. But let's go ahead and create the ball by going down into the back view, left mouse button, drag it up, holding the left mouse button down. And now we can drag out the other dimension of our ball, though, to sort of the Y dimension, the third dimension. Okay, so over here in the perspective view, if we swing it around, you'll notice that we have a nice ball object in there. Now I can also do the numeric requester for the ball as well. If I pull that up right now, it's going to have the current settings that I have drug out the ball with right now. And you'll see if I go in and on the spinner adjust the sides or the segments of the ball, so you'll watch the ball, more and more geometry is being created on that ball, and it's becoming a higher resolution object, so to speak, because it has much higher number of points and polys in it. Consequently, you'll notice if I go way down in the segments, our ball looks kind of chunky, and we can actually see what we call facets, which is actually the individual polygons that make up this ball here. The more sides and segments that we add to this ball, the smoother that thing will get. Alright, so just crank up those sides and those segments and you'll get a nice smooth ball. You don't have to go crazy with the ball to get it to be very smooth, because remember, when we take this into our rendering package, there are tools like smoothing that we can use that will actually do some of that work for us to make the ball appear to be shaded smoother than the geometry actually is. But if you're doing something like a planet, one of my pet peeves is that people that do planets don't put enough geometry in the planet. And as you look at the edge of the planet, you'll actually start to see these little angles, the facets that make up the geometry of the planet. And it really sort of destroys the whole illusion that this is a real planet and not just some computer-generated thing. Okay, one other thing that we can do in this numeric requester for the ball is a different type of ball object. Right now you see our type is a globe, and now if we go in and click tessellation, it gives us a level here. Now you'll notice that this ball is sort of a Fabergé egg kind of looking thing with lots of different facets that don't look like the globe did. The globe looked very regular and very sort of symmetrical in its rings and its segments and its sides. And the tessellation is actually made up of triangles instead of quads. And if we go in and adjust the level, you can see that this ball will become smoother and smoother the higher the level. Now we put on a level 4, that's a lot of geometry in there, and that's a pretty smooth ball right there. So I usually just go ahead and stick with the globe instead of using a tessellated sphere. It may just be because that's the way I've always done it, but I've never really found much of a reason to go with the tessellation, especially with a tessellation of 4. You can really get into some huge objects there. And the more polygons you have, the longer it takes to render. So try to get away with as few as possible and still make it look good. Okay, so I'm going to close the numeric requester for the ball. I'll just hit the space bar to create the ball, and now we have our ball object. Okay, let's take a look at some of the other primitive tools that we haven't covered yet. Okay, we were ready for, we already kind of covered disk a little bit, so I'm going to go ahead and skip down to cone. And cone does basically what you might think it does. It will create a cone. So we can drag out the base and then drag out the top of it. Nothing too fancy about that, and no surprises there really. So that's how you can create a cone. And spacebar obviously creates the object. And got a nice little cone. Alright, now let's talk about the sketch tool. And if I select the sketch tool and then just, you can kind of see I have a little, looks like a pencil or a crayon that my cursor turns into. If I just click on my left mouse button down here in the back view and draw some curves here and let up, you'll see it actually creates a curvy kind of polygon looking thing. And if you look in the perspective, it actually shows up there. This isn't a polygon, this is just a spline curve, and we haven't really gotten to spline curves yet, so I'm not going to touch on them at this point. But if we go into the numeric requester of Sketch by hitting N, you can see the type right now is set to curve. We can also set it to face so that we can create polygons right away. So I'm going to go ahead and say face and get rid of the numeric requester, delete this curve, and do the same thing, only this time I'm going to create a face instead of a spline curve. Boom, there you go. So that's a polygon like any other polygon. You see that it doesn't show up here in the perspective view. That's because, like we talked about before, it's a one-sided polygon. If I flip around, there it is, and it's there, no problem. So if we want it to be visible, again, we can just hit the F key to flip it around. Okay, so that's kind of the basics of the sketch tool right there. Not a very complex tool, just kind of cool for making freehand sort of forms with it. Okay, now the next thing I want to cover is the text tool. But before we do that, I need to put some fonts into the system, into Modeler, to choose from when I use the text tool to type text into the interface. So I'm going to go up here to Edit Fonts, select that, and you can see I already have a few fonts loaded in here, but to load a font in, one of the easiest way to do it is just say Add True Type Font. You can add a Type 1 font if you want to. Probably if you're using a Macintosh, you're going to want a Type 1 font, which is a PostScript type font. But on a Windows system, I can say Add True Type, and it brings up your standard Windows font requester. And then I can just go down through here and kind of look at the samples, pick out one that I like. That one's a bit wacky. We'll try this Arial narrow. Regular is fine. Italic bold and bold italic don't really matter, so just keep them as regular. The size doesn't really matter. The default is fine. So I'm going to say OK. And you'll see that the Arial narrow gets put into the font list. OK, so now that we have some fonts loaded into our system, we can go and select the text button. And now I'm going to click my left mouse button, and you can see I get this little text widget here. And I'm just going to type some text into the screen by typing on the keyboard. LightWave, LightWave. Okay, now I'm going to pull this out just a little bit. There we go. And in this text widget I can do a couple of cool things. I can use this top little bar on the widget to size the text up and down. So I left click on that, hold it down. As I move it up and down, you can see the text sizes up and down. And you can also see this little widget in the middle here. If I left click and hold down on that, move it left and right, I can adjust the kerning or the spacing on my letters. Now I can also pull up the numeric requester for this, but you'll notice if I try to type this in, let me just move this over a little bit. If I hit in for numeric, it actually types it into the text string along with LightWave. So if I hit backspace, I can get rid of that in. To bring up the numeric requester, if I'm already in the text tool, I need to go ahead and click on it in the interface instead of hitting the in for numeric. So I'll click on numeric. That brings up my text string requester. I can go through here and change the font as I want and see it update, which is pretty neat if I'm not sure what font style I really want to use. I can also change my alignment. Right now it's left justified as is relationship to the text widget. And I can say, no, I want that centered. And you can see it's centered on the text widget now. Or right justified, and I have to move it over here for you to look at it. You can move this by just clicking on this part of the text widget, holding down your left mouse button, and you can move it around. I can also determine which axes I want it to go on, and right now I have the Z selected, so it's showing up in this window. Do X, Y, and Z. You can see it changes the orientation of the text. And I can scale it and add different center points for it, adjust my spacing, and all the things that I can do sort of with this little guy I can do in the numeric requester as well. So that in a nutshell is the text tool. Okay, so I'm going to get rid of that. And now we can take a look at the pen tool. Select it. Basically what this lets you do is just clicking, I can create polygons without having to go in and create the points, then select the points, and then make a polygon. It automatically makes the polygon for me. So now you see I've created the cross-section of a potato, which is exactly what I meant to do. Not really. It just kind of happened by accident. But anyway, that's the pen tool. It's just an easy way of creating a polygon, and to actually create it now I need to go ahead and drop this tool by hitting the space bar. And then if you look in the perspective and I rotate it, again it was flipped around the other way. So I need to rotate it or do a flip on the polygon. Now one thing that you'll notice is if I get rid of this, I'm going to delete it, so Z. If I start clicking the other way, go back and select the pen tool. If I click the other way, counterclockwise, I don't have to flip it, because depending on how I select the points and how I draw out the points, my normal will face the opposite direction. So it's actually facing at me now. Just an interesting note. Okay, and there's one last thing under this panel that I'd like to cover, and that's the spline curves. And let's take a look at how those work right now. Okay, just plot out a few points using my right mouse button. Okay, now you can see here under elements we have open curve and closed curve. And if I select open curve, you'll see that my points are all connected by this sort of curvy line here, and that is the spline curve that I talked about earlier with the sketch tool. Now you'll see I can select one of these points on this spline curve and move it around. So I'll select T for move, and just move that guy around. You'll see that the curve adjusts to wherever I move any of these points. Let me select another point, move it around, and it just adjusts to however I move it. The curves going into it and out of it adjust. And I can move it in the other views as well. But before I do that, I want to freeze this curve and make a polygon out of it. And the way you do that, I'm going to deselect this point, is just the keyboard shortcut is Control-D, and that will make the curve be frozen into a polygon. And again, it's flipped, so I'm going to rotate this guy around, and you can see the curve that I had drawn out is now frozen into a polygon. That freeze tool is right here under the Construct menu under Curves. It's ghosted out right now because I already recreated the polygon, but if I undo my polygon creation, you'll see that I just have the curve there now, and I have that freeze option available to me. And if I click on that, it'll freeze that. Now, I'm going to undo this a couple more times. Actually, I'm just going to kill the spline curve by hitting K. And so that leaves just the points. Go back over to Create. I'm going to select those points again, and I'll show you how we can create a closed curve just by clicking on Closed Curve. Okay, now my curve is closed. If I select one of those points and move it around, you'll see that it stays closed no matter what I do. And I can freeze this as well. So Control-D to freeze, and then I'm going to F to flip, and there I've got the polygon that I created using those curves. Okay, now that we've looked at a bunch of the primitive tools, we're going to look at the Modify tools, which allow us to modify existing geometry. So let's take a look. Okay, so I've created a ball here so that we can see the effects of the Modify tools on it. And so I'm going to go over to the Modify panel. And the first thing we see is Center. And I'm going to move this ball kind of off center here for a second. And you'll see if I click on the center button, boom, the ball snaps back to the center of the world, to the 0, 0, 0 coordinates right in the center of it. This will work for any object that you've built. It can be irregular shapes or what have you, and Modeler will calculate the center point on the object based on where all the points of the object lie in space. Okay, we can also use the F2 keyboard equivalent. So if I put that off and hit F2, it snaps right back in there. That's the way I usually use the center command, is by hitting the F2 key. It's just kind of habit right now. Okay, we've already seen how the Move tool works, allowing us to move things around. We can also pull up a numeric requester for the Move tool and some of these other tools as well. If I pull that up, I can specify exactly where I want things to move to, and after I've specified that, I can just say Apply, and it will automatically snap to that position. Okay, so we'll center that back. Alright, so Rotate, we click on the Rotate button, allows us to rotate our object around a pivot point, and the pivot point being the cursor. So if I go right here and hold down the left mouse button and move my mouse right and left, you'll see that the object is pivoting around where my cursor was. If I move it into the center, you'll see that it rotates around that as well. And if I go down to one of these other views, you'll see that it rotates wherever I tell it to. Again, it's one of those tools that if I pull up numeric, I can go in and adjust the angle exactly how I want it to rotate, say Apply, and it complies with my demands. Alright, so I'm going to undo that. Moving on down to the Size tool. The Size tool will uniformly size up or down this object. And it does it from wherever the cursor happens to be when you engage it. So you'll notice if I put the cursor right sort of around the edge of the ball here, hold down the left mouse button and start to move it, it sizes up and down, away and to that point in space. Okay? If I put the cursor in the center of the ball and engage the size tool, it sizes up sort of uniformly from the center of the object. All right? Stretch works much the same way, except it's a non-uniform sizing tool. In other words, I can go in here and hold down the left mouse button and move my mouse up and down, and I'll be stretching along the Z-axis. And if I move it right and left, I can stretch along the X-axis. And if I'm down here in the back view, stretch up and down along the Y-axis if I want to. And you'll notice that if I stretch on the Y-axis, I might kind of get some stretch on the X-axis, and vice versa. If I stretch on the Z-axis, I'm kind of getting some stretch on these other axes. Well, if I just want stretch on one axis, I have to constrain the tool. And to constrain these tools, I can hold down the Control key down here, hold down Control, and now if I stretch, hold down the left mouse button and stretch, you'll see I can keep the ball from stretching on any of the other axes. And this also works on like move. So if I go back and select move and hold down the Control key and move it along an axis, you can see that I'm really kind of moving the mouse not really precisely, and it's constraining it along one axis. And so if I do the same thing down here in the back view, I can just constrain how that's moved, moving the mouse left and right. Okay. Now let's talk about drag. Drag lets me drag points around without actually selecting them. So I'm going to go ahead and select the drag tool, and I'm going to zoom into a specific point on my object. Now, one way I can do this is by moving my viewport around, as we've seen before with the pan, and then zooming into it with the little magnifying glass here. But another way I could do it, if I wanted to go to this exact point in my object, is to use the Go To command, or the G keyboard equivalent. So if I place my cursor where I want to go and hit G, boom, it snaps that to the center of my viewport. Okay, so I'm going to zoom into that point. And now you'll see if I put my cursor over the point, hold down the left mouse button, I can just start grabbing these points, dragging them sort of arbitrarily without having to actually select them. This is quite a handy little tool when you're modifying existing geometry, especially when you get into some of the more advanced features of Modeler. You'll probably end up using this drag tool a lot. And it saves you time because you don't have to go in and select the points first before you start moving them around. It's kind of a combination select and then move tool. And it's a good thing to know how to use. Okay, so I'm going to undo my little perturbations here on my ball. That's fine. It tells me I cannot undo the previous operations because I've maxed out the number of undos that I have set up. Right now my undos are set to 8, but I could set those a lot higher if I want to. Okay, so I'm going to center this up on the screen, and we're going to go right down to the shear tool under the flex options down here. Now what shear is going to do, it's probably easiest just to take a look at it first of all, is going to shear my object on an axis. So you'll see I hold down the left mouse button and I start to move, and the shear is happening from top to bottom here. You can see that the top is moving a lot more than the bottom is. Now I've let up on the left mouse button, so if I undo that and redo it, you'll see that as I keep shearing it and keep shearing it, the top will just keep moving more and more, and the bottom will not move as much. And again, I can shear this all around if I want to, or I can constrain it. I hold down the Control key again and constrain it to that one axis. Now, for some of these tools, it seems to me that usually it does exactly the opposite of what you want it to do, and it just kind of seems to be the luck of the draw. Nothing that Modeler is doing wrong. It's just Usually, the modeler has to figure out, okay, he must want to shear this way, when in fact you wanted to shear the other way. Let's say I wanted to shear the bottom instead of the top. Well, the way that we would do that is go into the numeric requester for shear, hit the N key, and I can change the shape of my shear. And right now you see it has this shape right here. It's a little kind of wedge shaped thing. If I select the opposite shape of that wedge and then shear it, you'll see that the bottom is now shearing instead of the top. And there are other options in here as well, which you can play around with, and they're quite useful. All right, the twist tool will kind of let us twist our object in sort of a uniform way. So if I select the twist tool and put my cursor in the center of the ball, hold down the left mouse button and move my mouse to the right, you'll see that the entire object gets kind of twisted from top to bottom. You can see it happening there in the perspective view as well. And you can also do that, I'm going to undo that, from an arbitrary sort of place on the object. I don't have to do it right in the center. If I do it sort of from the side here, you'll see it starts shearing things in kind of an odd way, depending on where my cursor is. So you can do some really kind of wacky things with twist, depending on what you want to do. All right, let's talk about taper. Now, taper 1 is a uniform taper, and it affects the entire object uniformly. So if I hold down the left mouse button with the taper control or taper command centered, and hold down the left mouse button and begin to move my mouse left to right, you'll see that it tapers off the object depending on how I move my mouse. Now again, it's one of those things where, you know, no, I wanted to taper the other way. Why won't it let me taper the other way? Well, modeler has to at least pick one way for you to taper, and it seems to me that most of the time it's the wrong way. I don't know why that is, but fate, I guess. So we can pull up the numeric requester, and again we can change the shape to the opposite of where it was, and go back, and now you'll see it's tapering the bottom instead of the top of my object. Get a little hot air balloon action going down here or something. All right, and I'm going to undo that. Taper 2 allows me to taper on a non-uniform basis, much like stretch allowed me to size up on a non-uniform basis. So if I hold down the left mouse button and taper, you'll see that I'm tapering in a non-uniform way. You can see it over here in the perspective a little bit better. And I'll just do a little taper action this way as well. So non-uniformly being able to taper the objects. Now, I can also drag out these little widgets here using the right mouse button that kind of show where the taper is going to be affecting the object. And this is pretty cool. So I can define an area of the object without having to go in and select points or polygons or what have you to tell modeler that that's what I want to affect. So you can see right now, if I move my taper tool, that I'm tapering within the little widget here, and if I move the widget around, drop it and re-drag it out from the top, and now I select the left mouse button, that the entire object gets tapered within there. Okay? Alright, now this is getting kind of munged up here, so I'm going to go ahead and make a new ball object. So I'll pop back over to Objects and drag out a nice shiny new ball here. Okay, back to Modify. Alright, let's check out Magnet. Magnet will let us deform this object in sort of a predefined volume way. So if I go to select on the Magnet tool and holding down my right mouse button, I can define the area of influence for the magnet. And this area of influence is a spherical area, or it can be a non-spherical as far as like an ellipse or what have you. But I can drag out that volume to however the dimensions I want and whatever position I want. So if I hold down my right mouse button and click the little cross in the middle, I can move that area of influence around. Now you'll see if I hold down my left mouse button and start to move that the area of influence are really the only points that are getting moved around using the magnet tool. So that's kind of cool. If I let go of the left mouse button and drag with my right mouse button, drag that area of influence out some more, and then hold down the left mouse button again, now you'll see even more points are being affected by my area of influence for the magnet. Okay, another useful tool. Vortex is kind of like a twist, except it does it in sort of a non-uniform way. So if I hold down the left mouse button with Vortex selected, well, first of all, I need to drag out the Vortex area of influence, much like the magnet tool. Move it over. If I start vortexing this thing, you'll see that it starts to swirl the polygons around the center point. And I can really mess things up here if I want to. I'm going to enclose my entire object in the Vortex tool. This is a good way to generate non-planars, let me tell you. And so after you've performed some of these wacky deformation tools, like this Vortex, you could find yourself with a bunch of non-planars, especially if I go in and grab just a chunk of it and offset it from the entire object. And if I do it too much, yeah, I'm going to probably start running into some problems here. And you can see I'm really smooshing this object up here. But maybe that's the effect you're going for. But like I said, if we want to create non-planars, that's probably the way to do it. Just a quick check. We'll pull up the polygon statistics. I had the points selected. We want polygons. Polygons, W. How many non-planars do we have? All of them are non-planar. Okay. So how can we fix that? Ye old triple. So Shift T, triple. No non-planars anymore. All right. But anyway, the point being that you can really mess up your geometry with those tools, and now you know how to fix those. All right, let's talk about pole 1 and pole 2 a little bit. Pole 1 is another uniform sort of deformation tool that allows you to drag out a volume, just like magnet and vortex do, of the area that's going to be influenced. So I'm going to center this up in my object. Now if I go ahead and engage the pole, you kind of see that it has kind of a, I don't really even know how to describe the pole effect, but it uniformly stretches the points away from the area of influence or towards the area of influence, and just as kind of a unique sort of deformation tool. Now we can also do a pole 2, which is only on 2 axes instead of 3 axes. I'm going to drag that out. We'll cover the whole area in the pole 2 here. Okay, so my entire object is enclosed within it. I do the pole 2. You see, it's not quite the same as stretch. It actually deforms the object quite a bit differently. And we can go in, I'm going to undo that. We can go in and actually, let me redo that one more time. You can see down here, I'm going to zoom out, that it's kind of creating these curved edges instead of what stretch would do, which would be to stretch the object out and give it more of a football shape. This is giving it kind of more of a donut shape on the side. But again, all of these have numeric requesters that we can go in and adjust things on. And here you can kind of see the shape of the pole for this tool. And we can go in and adjust the shape by sliding these sliders around, make it a very sharp effect. Or we can make it even more kind of a rounded. So if I create a very sharp effect and then go back and apply it, and it's kind of hard to see the, there we go. the area of influence is affected by the shape that we drag out in the numeric requester. Okay, so the best way to understand those tools, to really understand those tools, is to just play around with them a little bit on lots of different types of geometry and see how they affect it. Okay, so let's try Dragnet, which is not the TV show, but it's the combination really of the drag tool and the magnet tool. And what that lets us do is drag out an area of influence again. And you'll see this time it's really a 1D area of influence that we're able to drag out down here. So if I select the back view, it drags it out in that axis, and if I do the top view, it'll drag it out in that axis. And once you have that area of influence selected with your holding down your right mouse button, you let up on it and it remembers that. So I'm going to go to a specific point on my object. I'm going to zoom into that again. And now if I grab that point, I'm actually pulling that point around, but I'm also getting the points that were included in the area of influence that I just drug out seconds ago. But the difference between this and magnet is, let me undo that, that I have to actually click on a specific point to engage the effect. If I'm in the middle here and I click the left mouse button and I move the mouse around, I get nothing. So again, you select a point and you can go in and start pulling and deforming your geometry in that manner. Okay, I'm going to undo that. Alright, one last thing before we leave this panel is the symmetry tool. And I'm going to go ahead and select that. Okay, I'm going to select some points. Now you see what happened there? I selected a point, and the point that corresponds on the other side of the axis gets selected as well. And so this is kind of cool because you can go in here and you can say, okay, I'm working on a symmetrical object and I want to make all these changes, but I only want to do it to one side at a time and make sure that the changes correspond to the other side exactly as well. And so with symmetry turned on, any changes that you make on your object, on your symmetrical object on this side, will show up on this side. And so I've got these, let's just do a dragnet on one of these points here. So I'll select dragnet. You can see symmetry stays selected. And I'm just going to select one of these points and start to pull it out. And you'll notice that the points on the other side are doing exactly the same thing that the points on the side that I clicked on are doing. And so this is kind of cool, especially if you're making characters or faces. You start designing a face for a character, you really only need to be working on one side of it to get this, and using symmetry you can get those changes to show up on the other side of it. And you'd be surprised how many times that this tool will come into play for you now. It's a very, very powerful tool that just showed up in LightWave 6. And before we had this tool, we would go in and we would have to make our modifications on half the object and then mirror the object across and then merge those points and go through a bunch of rigmarole. This way it's very simple. If you've got an airplane or a car or a boat, something that's a symmetrical object, you can go in and just start making those changes and it'll appear on both sides. Okay, so now we've seen how to create geometry, how to modify geometry. Let's see how to make multiple copies of geometry and add to existing geometry. Let's take a look. Okay, so for these multiply tools, I'm just going to drag out a simple plane object and space to create that guy. Okay, so we've just got a flat plane over here in our perspective view. Now I'm going to click on the Multiply tab. And the first thing that we see up here are these Extend tools. And the first Extend tool that we have is Extrude. And so I'm going to go ahead and click on Extrude. And I'm going to hold down the left mouse button and move my mouse up. And you'll see what's happening is I'm actually creating geometry from that original flat plane that I had. And so the more I stretch out my plane, the more extrusion I get. Now we can see this a little bit better. I'm going to undo that. if I go in, I'm going to kill that plane and just do a little bit of text here like we did earlier. I'm going to pop that up, and LightWave is still in there that we had before. That's fine, we'll use that. And then we're going to go back and hit our extrude again and start extruding that text out. And you can see over in the perspective view now, our once flat text now actually has some depth to it. So that's one of the ways that you can use the extrude is for doing logos, but it has lots of other uses when you get into some of the other advanced functions of LightWave. Alright, so let me kill that. There we go. Okay, so I'm going to go back over to the Create panel, select my little pen tool, and I'm just going to draw out a little shape down here in the back view. So I'll start clicking this little shape. Okay. Basically what I have here is the cross-section of a glass or a goblet, and I want to take this flat polygon and I'm going to lathe it around one of these axes and create a whole bunch more geometry just from this flat 2D cross-section of it. So if I go over to Multiply and select Lathe, and then I pick where I want the lathe to happen, what axis I want it to happen around, how far away from the original geometry I want it to happen, and so on. I can just go in here and I'm going to put it right on the center of this cross-section, this axis. Hold down the left mouse button, and you'll see if I drag it out, I can move my left mouse button, or move my mouse, and start to change the axis on which the lathe happens. So that's not the look I'm going for, obviously. But if I twist that lathe around on the axis, you can actually get something that kind of approximates a goblet of some sort and creates all this extra geometry from that one cross section. So that's kind of cool. Anything that's symmetrical type of object like a glass or what have you, you can go in and just create the outline of it and then use lathe to generate a full 3D version of it. So spacebar drops that tool and creates the geometry. Okay, well, while we got this glass up here, this goblet up here, fit it in here for a little bit. We're going to move to the Construct tab and select Knife. So I'm going to select on Knife, and I'm going to just go down here to the back view and start to drag out, holding down the left mouse button. I'm dragging out this line. If I let up on the left mouse button, I can go back and adjust the line, both handles. Now, if you take a look over on the right-hand side here, you'll see this ring that's being formed around here. Now, what's happening is it's showing me the new geometry that's being created interactively as I'm dragging this around. So, see, as I move, that ring moves over there as well. Alright, so let's just make this knife happen. So I hit the spacebar, boom, geometry is now created, and we have this cut through this axis. Wherever I drag my knife tool out, the axis I drag it out, that's the axis that the knife is going to be projected upon. So if I do it in the top axis here, select it again, drag it out, you can see I'm starting to get geometry being added in the top axis, the y-axis. Okay, this doesn't seem real useful for this object right now, and it's not for this object, but for some of the more advanced techniques that you'll learn in LightWave as your experience progresses, the knife tool becomes an invaluable tool. Space to create that. Okay, now let's take a look at the bevel tool. And I'm going to get rid of my beautiful goblet object here. and just go back to a ball. Alright, so let's go ahead and select bevel. Now again, as I said before, if you don't select anything in Modeler, it thinks everything is selected. And the bevel tool is cool because it's another one of those interactive tools that you find in Modeler. So if I just click down on the left mouse button and drag my mouse around, you'll see that all of the faces of this ball are being beveled. Kind of wacky. Alright, so I'm going to undo that. Now if I want to go in and just bevel one specific face, I can go in and do that as well. I'll just select one polygon here. And then I'm going to zoom into it. B for bevel. And then drag it out. And I can adjust how far out the bevel comes, and I can also adjust the inset of the bevel, or how far in it goes. Now we can also go in and obviously numerically adjust that as well. So I pull up the bevel's numeric tool. I can adjust the shift, the amount of shift on it, and I can also do the same thing for inset as well. And one other thing I can do is change it from an inner bevel to an outer bevel. If I say outer, now it's beveling the outside of it. You can see how sort of different that works. And then I can also have an option here under the numeric requester of a new surface. And what that will do is, if I select a new surface and I say this is the bevel, all the new bevel geometry that's created when I do this bevel will have this surface on it. So I can just keep beveling this stuff. If I bevel this guy out and drop the tool, B for bevel, drop the tool, B for bevel, it'll just keep beveling from the selected polygon that I have selected there. Okay, so again, you can probably figure out that that would be useful for beveling logo objects or what have you. You just do it with another primitive here with the box. Select just this top, B for bevel, and there you go. Now usually I use the inner edges instead of the outer edges for beveling. So anyway, there you go. Okay, now we're ready to take a look at another tool called Smooth Shift. Now you'll notice that when we did the bevel on the ball, that all of the, let me just do it really quick here, all of the polygons were acted upon separately. So create that and start to bevel. So yeah, all of those polygons you'll see are acted upon completely separately. And if I just had a few of them selected, they're still acted on as separate beveled objects. Now, if we want to have them acted on as one complete object, we can use Smooth Shift. So if I select Smooth Shift and begin to do that, you'll see that all of the polygons are acted on, and I'm actually shifting out from the object. Instead of being separate polygons, all of the polygons are being treated as one entire selected entity. So I can drop my Smooth Shift, select it again, just keep smooth shifting, drop it, select it again, and just keep smooth shifting out away from my original polygons. This is another cool way that you can create geometry very quickly from a simple mesh like a box with a higher res mesh or the ball like we have here. Okay, the next tool I want to take a look at is the Rail Extrude. Now, this is the first tool that we've talked about so far that uses two separate layers to create its geometry. And we haven't really talked about layers yet, So now is probably a good time to cover that. So let's take a look. Okay, let me just throw some arbitrary geometry in here. The old ball, the old standby ball. Okay, now you'll notice up here in the upper right hand corner of our screen that we've got all these little tabs, 10 of them to be exact, and those are the layers in Modeler. Now you can have much more than 10 layers, but for this exercise we're going to just work with these layers that we have up here. Now if I go into the next layer, right now I have layer 1 selected, and if I select layer 2, you'll notice that there's nothing in there. That's because these layers are separate, or can be separate, but they can also be combined. And if you notice that each tab is kind of separated by a little diagonal line, that means that each tab is split up into foreground and background. So if I select layer 2 as my current layer, and then I select the bottom of layer 1 where I put the ball, then you'll see that show up as black. And that means it's a background layer. And whatever I try to do, if I try to move it or what have you, I can't do it. So if I say modify move, it won't go because it's a background layer, and it basically means it's inert. So now if I take a box in this second layer, drag it out, you'll see that just as we've been working with before, it shows up. But I can also continue to see the box in relationship to the ball. Now if I move the box around, again, only the box moves because it's in the active layer. Now if I wanted to make both the box and the ball move, I would need to have both layers selected as foreground layers. And how we do that is by holding down the Shift key and going back and selecting the first layer again on the top tab. Okay, so now you'll see we have both layers as active layers, and they're both being represented as white in here. And if I do a move, then I'm moving both objects around at the same time. Now what Modeler gives you the ability to do is to have all these multiple layers here, so you can have different parts of your object that you're working on and keep them separated. So when you start getting into these complex bits of geometry, maybe you're building a space station or something, and that would have several chunks of geometry that sort of all fit together. Well, you don't want all of that on screen at the same time. First of all, it's just confusing mess because you'd have such a huge wireframe to deal with. But secondly, you may want to manipulate different parts separately from the other parts, and so you don't want to have to go through and select all the little parts individually. So if you keep the layers, keep the parts into separate layers, it's much easier to deal with bigger objects. Also, because when those are all set up in the separate layers, you can save them out as one object and load them into LightWave as one object but as separate pieces. So in layout, you'll bring in an object that was created in multiple layers. You can go into each one of those parts or layers of the object and manipulate it separately if you want to. So the layers are actually a very powerful part of Modeler, and you can also use them as reference. So if we wanted to look back here at our box and our ball, and we wanted to make sure that our box was sitting on our ball exactly, all we have to do is bring the box into the foreground layer, select the ball as the background layer like we did before, then we can just move our box in relationship to the ball, and we can see exactly where they should be in relationship. Then we can shift click and have them both selected at the same time. Now you can see I have my box perched exactly where I want it to be. Okay, so now layers also have another function. Other than being able to keep separate chunks of your object in separate layers so that you can work with them easier, the layers are used with some of the other tools. And the first tool we're going to look at that uses that is the rail extrude. So let's take a look at that. Okay, so we're going to get rid of this box and this ball, and I'm just going to create a simple disk. Drag that out. Make it a little smaller. Okay. And in another layer, I'm going to sketch out a curve. So I'm going to select layer 2 as my foreground layer. I'm going to go ahead and select layer 1 as my background layer so I can see where my disk is in relationship to what I'm about to create. So I'm going to create a curve that goes off in this direction. So I'm going to say sketch, start sketching out just a kind of a path for this rail extrude to follow. So this is my rail, and I'm going to extrude this disc along that rail. Now I'm going to go in and I'm going to drag some points of this rail around so you'll get a better idea that this is a 3D extrusion, but it's along a path. So I'm going to go ahead and say drag. Actually, let me size this up just a little bit. Okay, so now you'll notice that I've put my disc on one end of the rail, and now I'm going to go in and drag some of these points around in the top view so they're not all lying in the exact same plane, which is fine in this instance. Alright, so you can see in the perspective view, widen that out a little bit, if I rotate around, that the rail that I have for the disc to extrude along is all curvy and kind of winds all over the place. Alright, so now we're ready to extrude this disc along this rail. First thing we need to do is put the disc in the foreground layer and the rail in the background layer. Okay, so multiply, rail extrude is available now because I have geometry in the background. It wasn't available before because there was nothing in there. And I'm going to say rail extrude, and it gives me some options here. I can do automatic, I can do uniform lengths, uniform knots. This tells me how many segments I'm going to do if I'm using uniform knots or uniform lengths. If I do automatic, it will figure out how it should do the extrusion. So let me just go ahead and do the extrusion real quick. Say OK. Shebang. Now you can see what's happened here is it took my disc and it started basically extruding that disc with multiple segments around the rail that I drew out. And I'm going to zoom into the perspective view here, and you can see that we can actually see into the inside of this object here, and that's kind of wacky, and that was all based on the way the surface normal was facing in the disc object when it was first created. So if I undo this and select my disc, I'm going to hit F for flip, and you can see in the perspective that the surface normal is facing this way. I'll hit F, and now I'm going to redo the rail extrude. So rail extrude, automatic, OK. Now that's more like we wanted. And we can see the outside of our tube here. OK, so you can kind of see how Modeler just kind of smashed things together here as it tries as best as it can to get that disc around the rail. You may have some problems down here in this area. So let's look at some of the other options for rail extrude. I'm going to undo that. Click rail extrude again. Now we can say uniform lengths. And if we do that, it's going to space these out as uniformly as it can. Let me undo that and go back to the tool again. And right now it's set to 20, and that was kind of chunky. So I'm going to crank that up to like 40 some. And again, it tries to uniformly space these discs that are extruded the best that it can and still maintain the curve around the rail. So I can also say whether I want this disc to be oriented or not. And if it is oriented, it's going to try to orient itself along the curve. And so it's going to look at the shape of the curve, and it's going to angle that disc as it's extruded in relationship to the angle of the curve and as it approaches curves in the curve. So if we turn off oriented, you'll see that the disc object, as it extrudes, remains completely vertical and doesn't try to angle itself around the curve in any way. And sometimes you want that, and sometimes you want the other thing. You can see the difference in the effect here, especially in this area. If we undo that. Now if I go back in and select oriented and say OK, you'll see that again it angles the disc around the curve, following sort of the contour of the curve here. And sometimes you want that, and sometimes you want the other effect, but it all depends on the project you're working on. Okay, let's take a look at a couple of other tools. We'll look at the skin tool and the morph tool. Alright, so let's get rid of this. Don't need that anymore, so I'm just going to be working in layer 1. I'm going to go ahead and create a couple of disk objects here. Okay, I'm going to create one more disk. I'm going to make this disk have a different number of segments, so I'm going to go into numeric and drag the number of sides down so it's a little coarser than the original, and create that. Okay, so to use the skin tool under multiply, we need to have 2 polygons selected. And so I'm going to go ahead and select these 2 polygons, that guy and then that guy. Now you'll see the skin tool becomes available. Basically what it's going to do is it's going to try to join these 2 polygons together by adding geometry between the 2. So let's take a look. So I hit the skin, boom, okay. Now if we look in our perspective view, again you'll see we're seeing inside of the geometry that was created. Now if we want to see outside, we could just do a flip on this whole object if we wanted to, or let's going to undo the skin. I can go in and I can flip this first polygon so it's facing opposite of the second polygon, and then I'll do the skin again, and now you can see that we have a surface generated around the outside. This is a very handy little tool if you have geometry that you need to join together with a surface, but you don't want to go in and by hand create polygons around by selecting the points and making polygons. Modeler will go in and do it for you. It also goes in and you'll notice that these are all tripled, and so it keeps you in good shape as far as creating planar polygons so you don't get any non-planar trouble. So that is a skin, and you see that's kind of a cool way to bridge between 2 polygons, and there's another way to do that with the morph. Let's take a look at that. The skin didn't care really about the number of points in our 2 disks that we skinned across, but the morph will. So I'm going to go ahead and create 2 disk objects here, and then I'm going to offset them slightly. First I'm going to go in and modify one of them by stretching him out a little bit, something like that. And then I'm going to move him so he's lined up in just sort of a haphazard manner here with my other object. Okay, so let's select both of these guys. And I'm going to flip both of those so they're facing outward. And now let's go in and do the morph. So if I go into multiply, morph, asks me the number of segments I want. The number of segments is how many segments are going to be created in between the 2 polygons. I say OK. Alright, and you'll see that again we're seeing the inside of the object that was created, and we want to be seeing the outside. So all we have to do is flip everything. I'm going to deselect it so nothing is selected, so now effectively everything is selected, and say flip. Okay, so you'll see what happened here is it actually created multiple segments in between our 2 polygons that we have morphed between. And it goes from this original shape. Let me bring those 2 end polygons back by just flipping them. Alright, there they are. It goes from our original shape and through the segments morphs into this next shape. And the difference between this and skin obviously is it gives us the ability to put multiple segments between the 2 objects instead of just having it skin across both polygons as one sort of mesh. The other thing to keep in mind with the morph is that your morph target from one disk to the next have to have the same number of points, or else it won't be happy and it'll complain to you. Alright, let's take a look at some of the duplicate tools. And these tools allow us to create multiple copies of our objects in a very quick and easy way. Let's take a look. Alright, so let's get rid of this guy. And I'm just going to go in and create a box. Okay, so let's go back to multiply. And first thing I want to look at is mirror. And mirror allows you to mirror an object to one side of an axis. So I've already got my little box here. If we select the mirror tool, this is also an interactive tool. So if I click the left mouse button, you'll see that depending on where I drag my axes, the mirror will be created. And this is pretty cool because you can generate the mirror on any arbitrary axes instead of just the rigid X, Y, and Z axes. And I can interactively control that. So if I want an exact mirror on the other side of the Z axis, I can just line it straight up, hit the space bar, and now I have an exact mirror of this box object over on this side. If I select mirror again, then you'll see now I have the mirror of both boxes. So that's a very handy feature. So now let's take a look at the clone tool. I'm skipping paste because we've been using that already. That's just the paste of copy and paste. I'm going to get rid of one of these boxes here. Okay, and I'm going to center this box up. If I click on clone, it brings up this big requester that asks me lots of questions like how many clones do you want? Where do you want the offset to be? What do you want the scale to be, the rotation, and what have you? So if I just say I want 9 clones for a total of 10 boxes, I want the offset to be, let's say, 290 millimeters on the Z. And that's all I select right now. If I say OK, boom, you'll see on the Z axis 9 copies of that box get created. Now they're all kind of smashed in together right now, and that's because I didn't give it enough of an offset. So let's go back to clone, and I'm going to crank that offset up a bit. So if you're creating something like a picket fence or something like that, that allows you to just create one of the pickets, and then you can easily clone that chunk of the fence and space it out evenly all the way down the fence. Now another thing you can do, click on undo, go back to clone, is say what you want the scale to be as the clones are made. So I'm going to just adjust the scale a little bit on these spinners. Say OK. Now you'll see something kind of cool where it takes the original object and each subsequent object it applies the scale that we selected there in the numeric requester, or in the clone requester. The clone tool has no numeric requester. It is its own requester basically. So you'll see that every time we've created a clone here, it's been adding this scale percentage to each subsequent clone. So you get some really nice architectural effects with that if you really play around with it. And along those lines, you can also do that with the rotation as well. So if I undo that, go back to clone, and I say every time we make a clone, I want it to rotate 15 degrees as it goes. I'm going to bump up my offset here a ways. There we go. Now if we take a look from the top down, you'll see that each subsequent clone is sized up and rotated as it goes along. And we can also go in and tell it what the center point is to clone around. Right now it's just going to use 0, 0, 0 because that's what the center is set to. But I can go in and I can say, no, I want my center point to be 570 millimeters on the X. And you'll see it starts to kind of curve off to one side, and that's because the center point is not in the center of the object anymore. So anyway, play around with clone. You can have a lot of fun and get some really cool effects with that. So you could actually go in, stretch this guy out to make a step, and then let's go in, pick the clone tool. Let's say we want 16 steps. We want the offset to be on our Y, so it's going up in the air. So let's say 370. I'm going to make my scale 100% across the board. And we'll leave the rotation set to that. Our center is going to be at 0. Say OK, and there you go. Instant spiral staircase. So, a very useful tool. Okay, next thing on our list is the array. I'm going to get rid of my beautiful spiral staircase there. Drag out my box again. And let's do an array of boxes. Now this lets me do multiple dimension arrays as opposed to Clone's sort of one-dimensional array. And you can see that we have array types. We have a rectangular array and we have a radial array. If we just take a look at the rectangular type, I can go in and adjust how many clones will be made in each axis. So along the X, let's say I want 5 clones. Along the Y, I want 4 clones. And along the Z, I want 6 clones. And my offset is going to be automatic at this point. And automatic just uses the dimensions of the object that I have dragged out, that I have created right now, as its offset. You see if I say OK, that those objects butt right up against each other because I had automatic selected. But you can see that I've created a multiple dimension array of those objects, basically a multiple dimensional clone of those objects. If I undo that, go back to array and make it manual instead of automatic, I can determine what the offset will actually be in all of those axes. Okay, so now you can see they're spaced out how I wanted them. Another very cool, useful tool. I want to move my object a little bit. So I'm going to move that guy off center. And I'm going to say, this time I'm going to say I want a radial array. And it asks me how many I want. I'm going to say I want, let's say 8. It's going to ask me what axis I want to do the array on. I'm going to go ahead and keep it on the Y, keep my center at 0, and say OK. Now you can see it takes this box object that I had and it makes an array using this as my center point. And you can see that I have a total of 8 of them right now. And so that's kind of a cool way to, in a radial fashion, make clones, have them rotate in the proper orientation as they're cloned around the array. Okay, the next thing I want to cover are the Boolean tools. And the Booleans always use 2 different pieces of geometry to create their effects. Let's take a look how that works. Okay, so I've already gone in and created our standby ball here in layer 1, and I've also created a box in layer 2. Now when you do Booleans, you're always going to want an object in one layer and an object in another layer. And so let's go over to the multiply menu, and you can see we have under combine, ghosted out right now our drill, solid drill, and Boolean. They're ghosted out because I only have a foreground layer selected. And as soon as I go in and select the ball as layer 1 and the box as layer 2, they become available. Now the first thing I want to start with is the actual Boolean tool. I'll get back to drill and solid drill in a minute. But if I hit Boolean, it asks me what kind of operation I want to do. And if I select subtract, whatever object is in the background is going to subtract from the foreground object. So let's just take a look at how that works. I'm going to do the subtract. Okay. Alright, so you can see where the box object and the ball object overlapped was subtracted. And in its place, this flat surface was created. And so that's a useful tool if you want to go in and cut chunks out of your geometry, and they can be any shape that you want to be. I could have used a ball, a cylinder, or what have you as this shape, as my cutter shape, as it's called, instead of a box if I wanted to. We basically sliced this ball down the side and created geometry inside of it. Now, if we actually wanted to slice this ball and be able to see the inside of it, we would have to have double-sided polygons in here. So let me undo that. I'm going to go ahead and double-side this ball. So copy, flip, paste, and merge those points, automatic. Alright, now we have a double-sided ball in here. And if we go ahead and do the Boolean again, the Shift B brings up the Boolean requester. Subtract it again. Okay, now this time we can actually see inside of the ball, and that is one of the reasons why you need to know the difference between single-sided polygons and double-sided polygons are for operations just like this. Okay, so I'm going to go back and undo that, and I'm going to undo my double-sided copy that I did. Okay, so now we're back to a single-sided object, and let's take a look at a few of the other Boolean selections. So if we do Shift B and say union and say OK, now you'll see that it adds both pieces of geometry together, but it doesn't keep the section of the ball that was inside the box. It does a union on both of them. They appear to be just sort of smashed into each other, but you'll actually see that when the Boolean happened, that the box, as the cutter, cut out the remaining part of my, my ball in here. So that's a union. Now let's undo that. And Shift B again. Let's do an intersect. Now what intersect is going to do is it's going to say whatever parts of the volumes, the box and the ball, are shared is what's going to be left. So let's take a look at that. So intersect, okay. The part of the ball that was inside the box is what's left now, instead of the opposite when we did the subtract. And I'm going to shove my box over slightly so it's not right on that center point. So it's kind of off a little bit here. And put the ball back in the foreground and the box in the background. Shift B. Now if we do an add, now you'll see if I zoom in here, it didn't just copy and paste the box into the object. It actually added points where the geometry intersects. So if I go in here and just delete this ball by selecting its polygons, you'll see that I actually have a hole inside of my box. Okay, so those are the Boolean tools. Now let's take a look at the drill tools. Let me go ahead and deselect these polygons and undo that union. Okay, so again, we have to have something in the background to do a drill. And for this, instead of having this cube back here, I'm going to go into a third layer, and with the ball in the background layer, I'm going to just do a little disk action and create that. Go in and select a few points and size that up. Stretch it a little bit. Okay, so we'll just use that little shape. And I'm going to move that away from the inside of the ball just for clarity's sake here. Okay, so you saw when we did the Booleans, we actually had a three-dimensional object inside of another three-dimensional object. Now with drill, we can actually take a two-dimensional object and project it through the three-dimensional object that's in the foreground. So let's take a look at how that works. Alright, if you look at perspective view here, there's our little star-looking object here. I'm going to flip that around so it comes into the front. Now, I want to use the drill tool on this to sort of project this object through the other object. So I need to put my my cutter object, my drilling object, into the background, and my object that I want to drill in the foreground. So ball is in the foreground, drill object is in the background. Now if you look in the multiply menu, you see that drill is selectable. So I'm going to say drill, and it's going to ask me some questions here. It's going to say, okay, what axis do you want to do this drill on? Well, if I do it on the x-axis, which is this way, nothing's going to happen, because essentially what I'm doing is projecting this object through the other object on the axis that I have selected here. And the only axis that's going to work right now, the way this is set up, is the z-axis, this axis right along here. And so you're basically saying, okay, if I were to do the x-axis, it would project it along this way, which is not going to work. And if I wanted to do the y-axis, it would project it along this axis, and it wouldn't ever hit my object that I want to drill into. So all we have to do is say z, And then we have these other types of operations here, the core, tunnel, stencil, and slice. Now let's go ahead and do a core. Say OK. Alright, so this is basically cored out that shape within our target object here. Okay, so what's the difference between these operations? Well, as you can see right here, that's what a core looks like. Now let's go ahead and do a tunnel. So now in the core, what we were left with were the star shapes, and now what we're left with the tunnel is the star shape has actually tunneled through our object and drilled through it, all the way through it, and left the original object there. So you can see the difference between a core and a tunnel. A core actually left the star shapes and got rid of the rest of the geometry, and the tunnel actually tunneled the star shape through and made it sort of a hole there. Okay, let's undo that. Back to drill again, and stencil lets us stencil this cutter object right to the surface of our ball object here, and we can create a new surface for it when it does it. So I can say, okay, I want this surface to be called the stencil surface. Okay, and here we go. Boom. Okay, now you'll see we still have our geometry here, and it doesn't appear that anything has changed. When you look into the wireframe, you'll see that it was actually stenciled onto the outside of our ball here. Now if we want to go in and select this using the statistics menu, we can say W. Let's go down here and we'll find the stencil surface and select that. And now you'll see that the stencil that we did is what is selected. Okay. Now that would be kind of cool if you were doing like a text and you want to put decals on things. You could do that with your text could be your cutter, and you could decal up a car or an airplane or whatever you want. Okay, and one more thing left in the drill is the slice. Slice does exactly the same thing as stencil, except that no new surface is created. So if I just say OK, boom, the slice is done, and it has exactly the same surface as the ball object does. Okay, so we've seen what this regular drill does. It has the implied axis, and you tell it what axis that you want to drill upon. Now if we do the solid drill, we need a solid object in the background instead of just this 2D flat object that we're projecting, because the solid drill is actually a three-dimensional drill. So if we go in here and let's create some depth to the little star object here by extruding it. So back to multiply, extrude. There we go. Create that. And now I'm going to rotate this star around. I have the power to do exactly what I did before, but along an arbitrary axis. So if I just go in here and rotate my three-dimensional cutter, we'll leave that in the background. So now if we go in and go back to multiply, solid drill, core, you'll see it does exactly the same things, except it allows me to do it along this arbitrary axis. So tunnel, cuts the hole in there again, undo, stencil, same thing, we'll use the stencil surface. Okay, so that's stenciling on there, and we can select that in the statistics menu. So you can see the difference. Instead of just saying being restricted to an X, Y, or Z axis, I can go in there and make whatever axis. And now just to be complete, we'll do the slice, and there you go. Okay, that's it for this tape. We've covered a lot of tools in Modeler, and the tools that we've covered are really the workhorse tools, the tools that you'll be using all the time when you're creating objects. Now the tools that we didn't cover are really advanced tools like subpatch objects, and those we'll have to save for another tape. So until next time, keep modeling.